Good day. This is our program for the nonlinear equations in numerical methods, which is the second method. So let's define first what is second method. A second method is a root finding algorithm that uses a succession of roots of secant lines to better approximate a root of a function f. The second method can be thought of as a finite uh, difference approximation of Newton's method. So here is our formula for the second method. Xi plus 1 is equals to xi minus x times f times xi times xi minus 1, then over f times xi minus f times xi minus 1. So you can distribute the f into the x. So there are many ways to write this second method. So now we are going to the code for the second method. The first thing that we do is that um, we we include this stream, I mean IP, the math, and this stdlib. Then we have here the formula given. So our formula given is x times x minus 2 times or 2x minus 5 or x3 x3 minus 2x minus 5. So here in the formula given, we can just change the formula here. Depends on what are the given. We can change that. But here is our example first. And then we put using namespace std. And then here are the main functions. We will float the x0, x1, x2, fo, f1, f2, and the e, or the e. Then int the steps from 1 and then n. And then we will set the position and floating point values in a fixed point notation. So here we set the position to 6, and then on the line 19, here are the inputs. We will enter our first guess, and then the second guess, the tolerable error, and then the maximum iteration. So here is the implementing the second method. So we will display the second method. Then we have here a do while loop, and then we will set it to fo is equals to f times xo, and then f1 is equals to f times x1. Then we have your if statement. F is equals to 0. If x is 0 is equals to f1, then it will show the mathematical error, and then it will exit. So here is the formula for the second method, just like this. So it is x2 minus x2 is equals to x1 minus x1 minus x0 close parenthesis times f1, or we can put this f1 times x minus 1, and then x times this x1 minus x0 over f1 minus f0. And then we also put here f2 is equals to f times x2. Then here is the iteration for these steps. We set it to 10, and then we have here the x0 is equals to x1, f0 is equals to f1, then x1 is equals to x2, f1 is equals to f2. Then here is the steps depending on how many iterations. And then it will show the not convergent, and then it will exit. So here in the while loop, we have here the absolute value f2 is great if is greater than e, then it will show the root of it, and then we will return to 0. So now let's run our code. So let's say our initial first guess is 0, and then our second guess is probably like 3. No, 1. And then our tolerable error is 0.0001. Let's make it like this: 0.00001. Then we will enter the maximum iteration, say 10. So here is our result for the second method. The first iteration shows that x2, where is it? Here our formula x2 is equals to negative 5.0000. The second iteration is 1.31, and then third iteration is 1.61. Then the fourth iteration 2.52. Fifth is the 1.97. Then sixth is the 2.06. Then also here 2.06 in the seventh iteration, and then the eighth iteration is 2.094. And then final iteration is 2.094551. Then we have also here the f times 2. So the first iteration is negative 1.20, and then up until the final, which is the negative 0.00002. And then our root is 2.094551, so which is here the final iteration. So that's it for the second method in nonlinear equations in numerical methods.